how many years. Okay, got to match up. Okay, now let me try to show you how we bring from here to here. It's actually a little bit from differential equation, which is you guys going to learn later on, but pretty simple, so I can show you guys right here. The technique I'm doing is called what? Separation. So I'm going to bring all the y on one side and the other variable, which is t, on the other side. So I'll multiply both sides by dt and divide both sides by y. I got what? 1 over y dy is equal to k times dt. See? Divide both sides by y, multiply both sides by t. Alright, and the left hand side is 1 over y dy, the right hand side k. K is a constant already, okay, dt. And you ask yourself, what derivative give us 1 over y dy? We learned this already. This is ln of y. Okay? dy means like y prime. So the chain rule in here, the ln of y derivative 1 over y and then times y prime is dy. And on the right hand side, k is a constant already, and derivative give me dt is just t. And then don't forget we have a constant c. See why? Because what? When you differentiate both sides of this line right here, ln of y derivative is 1 over y dy. On the right hand side, kt derivative is k times dt, right? Changing of t, and then the derivative constant is 0. Alright, so we have ln of one side equal to kt plus c on the other side. And ln of y means what? Log base e, alright? And the definition for log is what? Log base a in general of say anything of u equal to v. That means what? A to the v is equal to u. Exponent to base to the exponent equal to the number inside the log. Excuse me for a second. Alright, let's continue. So in here is this base e. So what? E is a base, raise the exponent right here, kt plus c equal to y. Okay? And you know what we do with the exponent? This is e to the c times e to the k times t equal to y, right? You multiply two numbers the same base, you add the exponent together. Okay, and what is e to the c? E to the c is the initial value when t equal to 0. Try it in, plug in t equals 0. What you got? T equal to 0. This is e to the c, right? And times e to the 0 equal to y to the 0. Y is a function in terms of t, by the way. Okay? And e to the 0 is 1, so e to the c is equal to y 0. That's why they're right here. Y is 0, which is the initial value, the original amount that you have. And this explains the formula. And you guys see that's applied a lot in, let me see. Compound interest. What else? Changing the population, or we talk about, you guys can look at the current pandemic that we have right here. Look at the curve, keep going up exponentially. Was this one right here? We try to flatten out the curve, okay? Not to spread the virus all over. That was the one. Okay, and this is pretty much for our section today, and I claim that all the examples in this section are going to go around just one formula. So I'll let you do it, because if I say it, then you guys don't have to think of it at all, and I want you to learn a little. So you figure out what is the population, the function that you have in here, and they're going to give you the constant rate of change, okay? Triple means what? K equal to 3. Double means K equal to 2. And money is 2%, 3%. And don't forget to convert 2% or 3% back to decimal. 2% means 0.02, right? 3%, 0.03. Could be a positive number, could be a negative number for the rate. And you set up the formula right here. The rate of change, instantaneous rate of change is proportional to the amount, K times, okay? And you have this, you immediately change back to here for me. You're going to look for the initial value, the original amount at the beginning. K is the same and t is a variable. Of course, in here I use y and t, but you may you see different variable when you get to the homework. Could be X and Y, could be S and T, whatsoever, but it's the same idea. All right. And let me stop the video clip right here. And as usual, should you have any question, please don't hesitate to ask. I'll try my best to answer all of them. Thank you, guys.